Okay, next topic in Module 8 is complex fractions, which means, again, you'll have fractions within fractions made of sums, so we're going to be adding, involving rational expressions. So that's a lot. What that might look like is also kind of a lot. Okay, so we are going to simplify this. And we have fractions within fractions. So what we want to do is find the lowest common denominator of all the individual fractions. Okay, so we're going to look at our 81 over x squared, our 2 over x, and our 63 over x squared. Okay, the smallest value that each of those denominators would go into evenly then is x squared. Okay, once we have done that, we multiply the entire fraction, so the entire expression, by that lowest common denominator over the lowest common denominator. Okay, so we're going to have 1 minus 81 over x squared over 1 plus 2 over x squared minus 63 over x squared, and that is actually not, that one's just x. Okay, and we're going to multiply that whole thing by x squared over x squared. Okay, so 1 times x squared is x squared minus 81 over x squared times x squared is 81 over 1 times x squared is x squared plus 2 over x times x squared, so that's going to be 2x, okay, and then minus 63 over x squared times x squared is 63. Okay, we have done what's called we cleared the fractions. Okay, that's a huge first step. It makes it look a lot easier now. From here, these types of problems you've seen before. Okay, so our next step would be to factor the numerator and denominator. Okay, so in this case, x squared minus 81, that's your difference of squares. So x plus 9, x minus 9. And then in the bottom, you can do whatever factoring method you want, but you should get x plus 9, x minus 7. Okay, and then our last step is to simplify. So we have an x plus 9 in both the numerator and the denominator that we can cancel out. So we have x minus 9 over x minus 7, or no parentheses. Okay, and that's your final answer. All right, so you're going to follow those 4 steps. Let me get another one for you to see. Okay, another example is if we had 1 plus 3 over x minus 40 over x squared over 1 minus 64x squared, over x squared, sorry. And you can see again, if you look at those 3 individual fractions, 3 over x, 40 over x squared, and 64 over x squared, again, your lowest common denominator is x squared, so I'll multiply by x squared over x squared. Okay, x squared times 1 is x squared. X squared times 3 over x will be 3x. You're going to pick up on some patterns here. 40 over x squared times x squared is going to be just 40. In the denominator, 1 times x squared is x squared. 64 over x squared times x squared is 64. Okay, now we factor using whatever method you want. That'd be x plus 8, x minus 5, and then x plus 8, x minus 8 with your difference of squares. And cancel out the x plus 8s. Again, you're going to see a lot of patterns in these problems, or they kind of have similar steps. And there's your final answer. Okay, it looked pretty messy, but it's not as bad as you would think. We're going to get to another one. Okay, kind of adding some more steps to these. The next one is complex fraction made of sums involving radical expressions. And this is problem type 6. So just a little bit different. Same idea, a little bit different. Example of this one is we have 1 over v minus 4 plus 5 over v plus 2 over 9 over v minus 4 minus 3 over v plus 2. Okay, we still look at all of our denominators and figure out what we can multiply by. So v minus 4 and v plus 2, we're just going to multiply everything by v minus 4 times v plus 2 over v minus 4 times v plus 2. Okay, distribute. One of those guys is always going to cancel out then. So when we do your 1 over v minus 4 times those two, the v minus 4s will cancel out. Okay, and we just have v plus 2. And then we take these same two guys again times the second term there. The v plus 2's cancel out. One in the numerator, one in the denominator. So we'd have 5 v minus 4. Okay, so it's the same first couple steps here. Same thing now down here. Your v minus 4's will cancel out, so we're left with 9 v plus 2. And then your v plus 2's cancel out. Oops, and it should be a subtraction sign there. And a 3. Okay, and we have v minus 4. Okay, so now again we've cleared our fractions. And our next step is to expand those top ones out, all the ones that have the coefficient, the 5, the 9, and the negative 3. So the v plus 2, be really careful with negatives, plus 5v minus 20 over 9v plus 18 minus 3v plus 12. We'll combine our like terms. So we got 6v minus 18 over 6v plus 30, right? Okay, so again, figure out your lowest common denominator and distribute. That will result in us clearing our fractions. Okay, we'll expand what's left. And then our last step is to factor if we can. Both the numerator and the denominator have GCF of 6. So 6 times v minus 3 over 6 times v plus 5. And those 6's cancel out, so we have v minus 3 over v plus 5. Okay, I'll get you another one of those. Next one we have 4 over v plus 8 minus 1 over v minus 4 over 1 over v plus 8 plus 2 over v minus 4. Okay, so same thing. We're going to take a look at those denominators and multiply to clear them out. So v plus 8 times v minus 4 over v plus 8 times v minus 4. Distribute it. Okay. So then when we multiply it by the 4 over v plus 8, we'll be left with 4 times v minus 4 minus 1 times all that. And the v minus 4's cancel out, so we just have v plus 8. And then in our denominator, v plus 8's cancel out, we have v minus 4 plus 2, v minus 4's cancel out, we have v plus 8. Expand, 4v minus 16. And I got to be real careful there. Okay, minus v minus 8 over v minus 4 plus 2v plus 16. So we've got negative 24 plus 3v And we've got 3v plus 12. Okay, so careful with your factoring here. You want to try to factor out the same thing if you can. Okay, so we'd factor out a 3 and we're left with v minus 8. I switched the order there. 3v minus 24 would be a better way to write it. Okay, and then factor out a 3 and we have v plus 4. So the 3's cancel out. Final answer, v minus 8 over v plus 4. All right, moving on. One more kind of tricky one, and then I think they'll start to get a little bit easier for you. I think this one can get real tricky. I'm going to give you a different way to do it than what Alex does. You can choose either way. And they actually have kind of two different types of problems in here. I think you've seen these before. In fact, I'm almost positive that this was a topic before in your prerequisite chapter. And I might have even showed you how to do it a different way in that video too. We're going to try, let's see, higher radicals, higher order. We'll see how this way goes. Okay, so an example on this one is we have the cube root of 2x to the 11 over 7y. Okay, your first step is going to be to split the numerator and the denominator. So we can rewrite that as the cube root of 2x to the 11 over the cube root of 7y. Okay. Now your next step is to multiply the denominator. Let me think about how I can write it. Multiply denominator, which will be in the form of the nth root of, I'm just going to say b. Okay, so by b to the 1 over n. No, n minus 1. Okay, so for example, if it was like the fourth root of 8x squared, okay, we'd multiply it by that same 8x squared to the n is 4, so to the 3/4. Okay, what that's going to do, remember, if the fourth root can be written as the 1/4 power. And what that does is, remember, if you have the same base, you add the exponents, and it will be 1 then. Okay, so this is just a little example within an example. Okay, so since we have basically 7y to the 1/3, we're going to multiply by 7y to the 2/3. And this is really important that you guys can go between those rational exponents and the roots, okay? Because we're going to keep the roots in the top, okay? So that'd be the cube root of 2x to the 11th, and then the cube root of 7y squared. Okay, because remember, this is the power, and this is the root. Okay, now 7y to the 1/3 times 7y to the 2/3 is just 7y. Okay, so we have simplified the denominator, not so much the numerator yet. All right, but just make sure you're understanding there that this is, the cube root can be written as the 1/3 power, and so we're going to multiply by the 2/3 power. Okay, and that we're keeping those rational exponents in the denominator, but in the numerator, we're going to convert it to the root and the power, okay? So that's kind of a big first step. Once you figure that out, the rest isn't so bad, okay? Our next step will be to use the power. Use the power. Okay, and by that I mean that power right there. Okay, so we're going to have the cube root of 2x to the 11th times the cube root. We're going to square the 7 and the y, so 49y squared over 7y. Okay. Next step, we are going to combine the roots. So we can write that whole thing as the cube root of 2x to the 11 times 49y squared, still over 7y. So that's a cube root of 98 x to the 11 y squared over 7y. I don't think they're going to give you any where you have to simplify that 98 or try to fit any perfect cubes that go into 98. It's possible, but I don't think they're going to throw any at you. And then from there, last step is to simplify the radical. So like I said, the cube root of 98, you'd want to see if you can split it into the cube root of a perfect cube and something else, perfect cube. So think about, 27 doesn't go into 98, that's a perfect cube. 8 doesn't go into 98, that's a perfect cube. 64, we're stuck. So we can't simplify the cube root of 98. The cube root of x to the 11, remember we can write that as the cube root of x cubed, x cubed, x cubed, x squared. Okay, so we can get an x cubed out of there and then leave 2 of them in there. Okay, remember the other way we talked about 11 divided by 3 is 3 remainder 2. So we can take out 3 x's and we have to leave 2 in there. Okay, and then obviously y squared, we can't simplify the cube root of y squared because 3 is bigger than 2. Okay, and then we're just going to put everything back together, reassemble. So we've got let's see, all we got out of there was an x cubed. And then we're going to leave in there the cube root of 98 x squared y squared over 7y. And then we would simplify if possible. And it's not. Okay. Those are some tough ones. I think that's probably the toughest one in this whole module. So if you're struggling with that, make sure you ask me. Let's do another example though too. This one, we're going to have the 4th root of 27b over the 4th root of 8a to the 7th. So this one, it's just you already have it split. So that first step is already done for you. Okay, so you might see some like this, and that's okay. The first step's already done for you. All right, so now remember that that's like 8a to the 7th to the 1/4. So we want to multiply it by 8a to the 7th to the 3/4, okay, which is the same as 8a to the 7th to the 3rd power 4th root, okay? So we want to have it with the root when we do the top. Okay, and then we want to do it as, well, it doesn't really matter. It's just we know the denominator is going to be 8a to the 7th, so it doesn't really matter. Okay, that's going to give us the 8a to the, ooh, that got messy. 8a to the 7th in the denominator. Okay, and then in your numerator then, we'll have the 4th root of 27b times the fourth root of 8 cubed. I'm just going to leave that as 8 cubed for now. A to the 21. Okay, and you'll see why I left that like that in a second. So we can combine that. The fourth root of 27 times 8 cubed. Maybe this is just going to be some big numbers here. Let me see. Yeah, it might be. 27 times 8 cubed. Oops, and I left the b and the a to the 21 over 8 a to the 7th. Okay, let me just check before we move on. Okay, so now what we want to do here is get your fourth roots. Okay, so split up that numerator, the fourth root. I'm actually going to split it up into the fourth root of 27 and then the fourth root of 8 cubed. Okay, and then we've got the fourth root of b and the fourth root of 21. Okay, there are no, so fourth roots get kind of difficult. So 2 to the fourth is 16. 3 to the fourth is 81. Okay, so there are no perfect fourth powers that go into 27. All right, now we're going to tackle at 8 cubed, okay, because it's going to get tough. All right, the fourth root of 8 cubed, that's your fourth root of 8 times 8 times 8, okay? We can get a 16 out of there, okay? We can write that as the fourth root of 8 times 2. Actually, we can get a couple of them out of there, right? 8 times 2 times 2. Okay, so if I just split one of those 8s up and use it to get my 16s, then I can write it as the fourth root of 16, the fourth root of 16, and the fourth root of 2. So 2 times the fourth root of 2 are 4 fourth roots of 2. Okay, so I'm going to rewrite that guy as 4 fourth roots of 2. That's tough. Okay, this is a tough problem. Again, if you're working on this and you want help, just call me over and I'll walk you through some of these. Okay, the fourth root of b, can't simplify that anymore. Okay, oops, I lost my a there. The fourth root of a to the 21. So 4 goes into 21 5 times. So I can take out 5 a's and I'm left with 1. Okay, so that's how my numerator breaks down. And what I can do then is take everything that came out, so my 4a to the 5th, and then leave everything that's left under the fourth root. So 27 and 2, so that's going to be 54, an a and a b. Okay, and then that's all over 8a to the 7th. Okay, so here's where I am right now. That's not my final answer because the 4 and the 8 can reduce to a 2. And the a to the 5th over a to the 7th can be an a squared. Okay, so my final answer, fourth root of 54ab over 2a squared. And that is a beast of a problem. Okay, that's a tough one. So again, I'll help you with it. Just let me know. And I think we're kind of long on this video, so I'm going to stop it.